Section 2.4 is all about complex numbers. So we've done complex numbers in the past, but let's just kind of refresh ourselves in this. So for example, a real number is the number 4. The imaginary number, by definition, is the square root of -1, the square root of -1, which we define as I for imaginary numbers. Now a complex number, every number can be written as a complex number, but this type of complex number would be 4 plus I, where it has a real component and an imaginary component. Every number could be written as a real component plus an imaginary component. Like 4, you could say 4 plus 0I. We just have to include a real component and an imaginary component. So for some examples down here, I'm skipping ahead. Complex conjugate. If you're dealing with a complex number like 6 minus 3i, the complex conjugate is 6 plus 3i. The overall message of that is take the opposite of the imaginary part. So to find the complex conjugate, take the opposite of the imaginary. So take the opposite of the imaginary part. Now, because complex numbers are numbers and they have real elements in them, we can work with them just like we would have done with real numbers. We can do arithmetic processes like addition, subtraction, multiplication, division, and we can leave it like that. We're going to focus on addition, subtraction, and multiplication for now. So, for example, 4 plus 7i is one group, plus 1 minus 6i. In order to do that, what we're going to do is we're going to add the like pieces together. This is combining like terms. So we have 4 plus, and again, making sure we're paying attention to the operator. 4 plus 1 gives us 5. Now, the imaginary part is we have a 7i and a negative 6i. So we have 7i plus negative 6i, giving us a grand total of 1i, or just I. And that's all. So it's just like combining like terms. They got to have the exact same variable, or in this case, it's got to be real, or it's got to be imaginary. So try letter B on your own. Watch out for the negative sign there. And you tried it. Let's move on. So real parts. We got 1 minus 4. 1 minus 4 is negative 3. Then we got 2i minus 2i. Well, that's really plus 0i. Really, we didn't need to write that, but we could. As I was saying, you can write every number as a complex number. But this one, we could have gotten away with just writing the real part. Now, for multiplication, we got to do what we've done similar to this with, this is a horrible sentence. We're going to do what we've done with binomial expressions, where we got a real part times a real part, but then we're going to have to do a real part times an imaginary part. Here's what I'm talking about. We're going to distribute. So 2 minus I times 4 plus 3i. We're going to take 2 times 4 and get 8. We're going to do 2 times 3i, which gives us 6i. We got negative I times 4, which is negative 4i. And negative I times 3i gives us negative 3i squared. We're going to have to think about the I squared in just a second. Now, just like we would do with a variable expression, we're going to combine like terms. So we have 8 still is by itself. We got plus 6i minus 4i, so that gives us plus 2i, and then minus 3i squared. Now we need to have a sidebar discussion about I squared. Well, I squared would be the square root of negative 1, because that's what I is, squared. In other words, I squared is just, well, square root squared is just cancels out. You're left with just negative 1. So whenever, sorry, I'm off the screen there. Whenever you see an I squared, I want you to think about replacing it with negative 1. So in doing so, we'll get 8 plus 2i, that I is fine, it's not being squared, minus 3, and it was times I squared, so it's going to be times negative 1. So which means we're going to clean that up. 8 plus 2i, negative 3 times negative 1 gives us plus 3. So when we combine our like terms here, we have 8 and 3, we get 11 plus 2i. Usually we're going to put the real part first, and this is no exception. I'd like you to take a moment, try letter D on your own, and pause the video and come back when you're done. And you're back. Here we go. So distributing again. So we got 3 times 3, which is 9, 3 times negative 2i, which is negative 6i, 2i times 3, which is positive 6i, and 2i times negative 2i, giving us negative 4i squared. just like we would do the variable expression, the negative 6i and the positive 6i, they're like terms, they cancel out. So we're left with just 9 minus 4i squared. But remember, just a minute ago, we said I squared was equal to negative 1, so we'll have 9 minus 4 times negative 1. Well, 4 times negative 1 is 4, so we have 9 plus 4. We get lucky number 13. So our final answer after we multiply those two numbers is 13. Taking a look at those, going back to one of our definitions, 3 plus 2i, 3 minus 2i, those are complex conjugates of each other.